Okay, so I've got a question here which is in 4 parts. So I've got a function g of x which is piecewise. So it comes in 2 parts. So for x less than or equal to 2, I've got x minus 2 squared plus 1. For x is greater than 2, I've got 4x minus 7. So the 4x minus 7 is represented here. And this first part, x minus 2 squared plus 1, is represented here. Now, I want to calculate compound function g of g0. That's the first part. Then I want to calculate when is g of x greater than 28, using that function there. Then I've got another function, h of x, which is just this first part of g of x. And we want to know, does h or g have inverses? And then this inverse function here, inverse function of h equals minus a half, need to solve that. So first of all, let's look at part A. So part A. So this is a compound function, g of g0. So first of all, let's calculate g at 0. So if x is 0, we can see from here, I have to use this function on the top. So g of 0 is 0 minus 2 squared plus 1. So minus 2 squared, because 0 minus 2 is minus 2. That's going to give me positive 4. And then plus 1 is 5. Okay, and then we're not done because we need to go again. And now I need to calculate g of 5. So g of 5, so when x is 5, I now need to use the bottom function. So I need 4 times 5 minus 7. So 4 times 5 minus 7 gives me 13. So that's pretty straightforward. G of g0 equals 13. So that's my first answer straight away. Now, when is g of x greater than 28? So I need to solve for these and find the critical values on the number line for when g of x is greater than 28. So let's use the first function first. So now let's just set x minus 2 squared plus 1 equal to 28 and get x on its own. So bring the 1 over the other side. So now I've got x minus 2 squared equals 27. That's subtracting 1 from both sides. Now I need to take the square root to get this x out of the square root and brackets. So now I've got x minus 2 equals plus or minus square root of 27. So remember the plus or minus. And now to get this x away from the minus 2, we just add 2 to both sides. So now x equals 2 plus or minus square root of 27. Now for this function, which is we came from this one, we need this rule here, x to be less than or equal to 2. Well, I've got 2 there, so if I add root 27, that's no good. So it's got to be minus root 27. So therefore x has to be less than 2 minus, now root 27, let's just put that into a shortened surd format. So root 27 is the same as root 9 times root 3, which is 3 root 3. So that's my first part. Now let's put into this one 4x minus 7 equals 28. So let's go here. 4x minus 7 equals 28. Add 7 to both sides. 4x equals 35. Then divide by 4. X equals 35 over 4. So therefore x is greater than 2, so that is valid using this function. So therefore x has got to be greater than 35 over 4. So I can write this as a solution set if I like. So I can say for x, I can put that as, it's got to be negative infinity to this, 2 minus root 3, in union with 35 over 4 to infinity. Okay, now as it's greater than, I use the rounded brackets. If it was greater than or equal to, I could use square brackets for these two. The infinity always goes with rounded brackets. Okay, now let's have a look at part C. H of x is just this upper part of g of x. And we want to know, does h have an inverse? So if h has an inverse, we need to look at this graph here. And g of x is the whole graph. Now, what we can do, we can call it the straight line test. So you get a ruler or a pen or anything, something like that, and just slide up the page parallel to the y-axis, and you're looking for, does my pen or my ruler ever touch two parts of a graph? If it does, the function doesn't have an inverse because it's not one-to-one. We need a one-to-one function. So one input, one output. So therefore I can see that g of x has got two inputs. So g of x doesn't have an inverse. But h of x, remember, is only the curve, so it's this one. So if I slide the ruler up, I'm only going to get one value for that. So therefore h of x does have an inverse. Okay, now solve the inverse function equals minus a half. Now what I can do here, there's two ways. I can find the inverse function of this, which is fine, but you could make a mistake on that. Or I can just write down this equation. Inverse function of x equals minus 1/2. Leave a bit of a gap. You'll see why that is in a moment. Let's just keep these calculations separate. And then I can take h, the function h of both sides. So I can apply that to both sides. Now it's valid when I've got this bit here, h minus a half, because the value of it has to be less than 2. Minus a half, obviously less than 2, so that's fine. And then what happens is on this side, I've got a function of its inverse function. That means they cancel out. So then I'm left with x equals h of minus 1/2. So if I plug in x is minus 1/2 into that, that's going to get my answer. So x equals minus 1/2 minus 2 squared plus 1. Minus half minus 2 is minus 5/2. So minus 5/2 squared plus 1. So minus 5 squared is 25. 2 squared is 4. So it's 25/4 plus 1. So let's put that there. 25/4 plus 1. So 25/4 plus 1, that's going to give me 29/4. So therefore x equals 29/4. And that'd be my answer for that one. So that's my answer to part C, and that's my answer to part B. Okay, that completes the question.